So I cleared away the transfer function last video. Now we talk about the power gain decibels. You just need to remember this one. This is related to the gain bandwidth. If you haven't watched the gain bandwidth video, you can go to the in the playlist is actually this name, op amps. And then you can go to gain band. Where is it? Within this it is within this thing lah. Okay, it's within this op amps playlist. It's actually the first video of the op-amp playlist. It's within there, you can actually take a look. So it's related to this power gain thing. So it's like a gain bandwidth. And then this also is a gain bandwidth. Okay, you need to know all these things. So now go through with this is quite straightforward. Right, and then now we talk about this thing. So what is actually this? When you are putting in a you have a series of filters connected or amplifier connected in series. Right, what you're gonna have? You have hold on, so initially I have a V in into the circuit, right? So you have a V1 out over V1, correct? So maybe I should write it down. So in this case, if you want to find the transfer function for this circuit, you have V1 out over V1 in, right? So this also explains why you have this thing over here, correct? So if you have a circuit at the second circuit over here, you have a V2 out over V1 out, right? So if you have to cancel out, you have V2 out over V1 in, right? So which is V2 out divided by V1 in. Alright, so this is, and nonetheless you can also re-represent it like this one. So what is this? This V1 out is actually V2 in also. So you can also say that you are taking V1 out over V1 in times V2 out over V2 in. So you can multiply transfer function by transfer function. So this is HF1. Okay, transfer function of the first one, and then the term multiplied by the transfer function of the second one. Right. So this explains why we have this function over here. So the transfer function total is just simply the multiplication of the two transfer functions. Right. So in order to find, what do you want to find? You want to find the transfer function of the ratio, right? Because what you would also know that V2, V out over V in is actually your gain, right? It's also actually your gain. Can be your transfer function, can be whatever things you are lah, okay? Efficiency value or whatever. So this V out over V in can be also gain. So we are actually calculating the gain through the gain through your V in all the way to your V out. Right, this is what exactly it is talking about. So in this case, we also have derived this one transfer function. You multiply your, actually I explained already. So we have last stop here. So in order to find a gain, if you remember, we talk about the gain bandwidth. If you haven't watched, you can watch it first. So to translate the gain into decibels, what you can actually do is actually to do 20 log base 10, and then the gain, which is V out over V in. Right? So in this case, our gain is actually this dude over here. Right? So this also explains why we have 20 log, and then this one is this one. So they are in a bracket, right? They are inside it. So with this one, you know that the logarithm rules state that A log BC is equals to A log B plus A log C. Right? So this is why this one becomes this one over here, and this one becomes this one over here. right? So after which, you can actually factorize out because they are all the same 20 log. So you can factorize out 20 log, 20 log. You will have the transfer function over here, right? Nonetheless, you have 20 log over here. Okay. So with this said, then you have a certain frequency, certain voltage. You can actually calculate your gain. So this is a continuation from your previous video on on this one, right? You have your V out and your V in already, right? So you have this formula, okay, and the inductor formula, if you remember, I forget what is it. Yeah. So you have this formula already, and then this is only one. Talking about only one circuit. If you have two circuits, you're gonna combine the two of the V1 and Vin, and then you multiply them together again. Okay, you multiply them together, and then you do a 20 log, that type of thing, in order to find your overall gain of the whole circuit. So this is a very good question to set up. So hopefully, I don't know. So it's good if you learn this. And then where are we now? We're talking about the cutoff frequency already. So the transfer function, as you know, is 1 over. Actually, you don't know lah. Okay, I don't know where does it come from. Great job. Hold on. I don't know where it spawned up. Okay, I don't know where it spawns. So just to let you know that this transfer function, okay, is 1 over 1 plus f over fc. This fc is actually your cutoff frequency. Okay, if your input frequency is equals to your cutoff frequency, okay, what do you have? It's very important for cutoff frequency. I actually didn't talk about it previously. So if you have a fc, okay, if your cutoff frequency is much larger than your input frequency, you're gonna have half power, okay, half gain, minus 10 log. Okay, if you remember if you want to convert your decibels, your gain to decibels, you're gonna convert with minus 20 log, right? So you're only half of it, so it's minus 10. So in this case, you have a lesser gain if your frequency is much lesser than your cutoff frequency. Okay, this is only for low pass. I don't know whether I got high pass or not. Yeah, this one is high pass. Okay, so low pass is actually this scenario over here. So in a more tangible way of saying, right, is that if FC is only 10,000, maybe F is only 2. So if 2 divided by 1000, you're gonna get 0.002, and if you square it, you have only 1, right? You only have 0.0000, which is very minimum. So 1 plus this 0. So 1 plus this 0.00000, you only have, in other words, 1 over 1, right? So in this case, minus 10 log 1 is equals to 0 decibel, which is, there is actually very minimum gain. Yeah, actually, sorry, it's over here. It's actually very minimum gain, as you can see, right? So this is only apply for f if your cutoff frequency is much larger than your input frequency. You have a curve that is start from 0 and then you go down. Okay, this graph is for this phenomenon over here, right? It's for this phenomenon over here. So by right, if it's minus 10, you should have a minus 10 slope also, right? In this case, because yeah, it's a minus 10 log, so you should have a minus 10 decibels, if I'm not wrong, right? You just stick to negative 20, okay? I see my notes, it says that it should be negative 20, but I don't know why is the reason why it's always negative 20 over here, although there's negative 10. Okay, anyway, so this is the situation where you have a cutoff frequency much larger than your input frequency. So if your so now, okay, okay, so let's remove all these things. This is all. So if your input frequency is much larger than your cutoff frequency now, meaning you have a gain much more, right? So if let's say this is actually 1000, this frequency is like 10,000, you have a more gain already, right? 1 over, if this is the case, you have 101, sorry, you have 1000, you have 10 squared is 100, right? 10,000 divided by 1000 is actually 10, and then you have to square it also over here, so it will be like 1 plus 100, 1 over 101, right? So if you were to take a logarithm of this thing, what do you have? Some values that is negative 40 decibels, okay, which is somewhat. So from this I can deduce, okay, if you take negative 20 log and then 1 divided by 101, you have some, maybe, alright, so I put in negative 20 log, okay, so negative 20 log, and then I put 1 divided by 101, I'll have 40.086. I have a 40.086 decibels going in this direction downwards, right? So in this sense, I would really think that, right, previously we talked about all this, things, right? This, hold on a while. So this negative 10 log, right, for some conditions, okay, if your cutoff frequency is much more than your input frequency, this formula takes on this portion over here up till the cutoff frequency, okay, so it takes till all this thing over here, alright. So if your frequency is larger than your cutoff frequency, you're gonna have this portion over here. So this explains why you have a negative 20 log. Okay, this is a very key important issue, and this is also why this is actually acting as a high pass filter, right? Because you have a very high cutoff frequency. Okay, you have a high cutoff frequency in this case. So whatever frequency that is lesser than this frequency will be filtered out. While if you have a frequency that is higher than your cutoff frequency, then you will start to you know what I'm talking about? What the hell? This is a low pass filter. This is a low pass filter, correct? So your low pass filter gonna filter out all the high frequencies, which is this one, right? So if your frequency is much higher than your cutoff frequency, you would go down and you isolate. So you only allow all the low frequencies to exist as this thing over here. So this is a very key concept that I want to convey for a low pass filter. And I think so the purpose of this section, okay, is that to calculate this portion over here is to plot a graph. Previously we do a lot of capacitor and the inductor, right, and then we talk about low pass filter, high pass filter, right? But how this graph is being generated is actually due to this thing over here, right? It's due to this. So in fact this is not linear at all. This is in a certain sense controlled by negative 20 log. Okay, so yeah, anyway. So hold on, let me see. Just a quick thing, okay? If it's a high pass filter, okay, this is actually a high pass filter now. Okay, this is actually a high pass filter. Hold on a while. So there's a typo error in the nodes itself. This should be a high pass filter. Okay? So the formula is a little different. Okay, if you were to compare to your previous one. Okay, you're gonna memorize these two formulas. Please memorize. Because you're gonna plot out all this stuff if they want you to calculate a certain things. So maybe I should brief you with this first. So if this is totally tobalic, okay, different thing. If your frequency is larger than your cutoff frequency, okay, your cutoff frequency is at this point. If your frequency is larger than your cutoff frequency, you have a signal. right? So this also explains why you have a minus 20 log minus 10 over here. So this is the equation for, so this thing, maybe I should, this thing talks about the line over here. Maybe, yeah, this thing talks about this line over here. While this thing, if your half frequency is larger than your frequency, okay, you're gonna have this line over here. So there's two different formulas governing two different trends of the graph itself, right? But nonetheless, this is the cutoff frequency for your capacitor, right? For your RC filter. This is the cutoff frequency for your inductor, RL filter, right? To be it high pass or low pass, you can use this one if it's a resistor and an inductor. If it's a resistor and a capacitor, you're gonna use RC, this thing, right? So how does the question will be? How the question will set is, maybe I don't think they will ask you to memorize this one. They will give you this formula, and then they'll actually call you to compare difference between I don't know. I think you might need to memorize also. So they'll give you this certain frequency, and they'll ask you to find the values. So if let's say I give you this frequency, and if your frequency is larger than your cutoff frequency, alright, you have you can actually draw this one. You deduce that your frequency is at this point, right? So if your given frequency is lesser than your cutoff frequency, you will have maybe at maybe some frequency at this point, you'll know that okay, you have certain this amount of gain, right? And then from here, then you can calculate your gain and such. So they will not give you any gain at the moment. So they will only give you the frequency, and then they call you to find the gain. So if you were to head back to the previous thing, we talked about gain bandwidth, right? You are given a certain gain and you're called to calculate the amount of bandwidth you allow. But nonetheless, you may also be given amount of frequency and you are asked to calculate the gain. And then for the gain, then you can calculate your gain bandwidth and such. So this is all the stuff lah, right? So yeah, so I've cleared all this, and then next video I'll talk about the rest lah. Alright, so hope see you in the next video.